Hi, let's take a look at how the graphing calculator can help us graphing basic functions, determine if a function is increasing or decreasing, and determine symmetries through the y-axis, symmetry with respect to the origin, and also if we have an even or odd function. So let's take a first look at graphing basic functions. Hopefully you're kind of familiar with using the grapher on the calculator. I chose these basic functions. I did not do the linear function y equals x or the identity function because that should be something we covered in another section. But y is equal to x squared, just to make sure you can enter that okay, you press your y equals key and then your variable x, and to square you can do the x squared key, or you can use a caret symbol with a power of 2. And then graphing in the standard window, we get that basic parabola. To enter y is equal to x cubed, we can go to the y equals screen, clear out what we have. Now we would raise x to the third power and graph. And remember, you can always look at the table if you want to by pressing second and graph, and there you can see the properties of oddness that we talked about, and we'll get more into that later on. Now to graph y is equal to the square root of x. Here we have to enter the square root function first, so we say y is equal to second x squared and type in the argument x and close parentheses, and now graph. To graph the cubing or cube root function, y is equal to the cube root of x, we have to go to another menu to get the cube root key. If we press the math key, do you notice option 4 is the cube root? So if we press 4 and then type in x and close parentheses, we'll get the cube root of x. Now, as a side note, some of you may remember that the cube root of x is equivalent to x to the 1/3 power. Same thing, really, the square root of x is equivalent to x to the 1/2. If you don't remember that from Math 28, that's fine, but a rational exponent is equivalent to a radical. So if I wanted to enter it with the exponent, I could do x raised to, and then in parentheses, 1 divided by 3. And I'll get the same graph. And then lastly, I want to show you how to use the absolute value function. If you press your y equals key and clear, to do the absolute value of x, I have to go back to that math menu, go over to the number menu, and number 1 is absolute value. So I type in the x and close parentheses and get the graph there. Okay? So make sure that you remember how to go through that. So for absolute value, I had to do math, arrow to the number menu, and then option 1 is absolute value. And if I wanted to do the cube root symbol, I had to do math, and then option 4, right, was the cube root of x. Now, to determine if a function is increasing or decreasing, problems in your homework where you had to just enter the function and it told you what interval to look at. So if I have f of x is equal to the absolute value of x plus 1, and I want to determine if it's increasing or decreasing from negative infinity to negative 1, I've already got the screen capture here, but I just want to go through the steps of graphing that on the calculator. I would press math, go over to the number menu again, type in my inside expression or my argument, which is x plus 1. Oops, let me enter that there. And close parentheses, and then graph. So you can see the picture that we have. So I need to look at what's happening from negative infinity to negative 1. Well, remember, this is talking about the piece of my domain, or the values for x. Well, negative infinity to negative 1 in the x direction is here. So I'm looking at what's happening to the piece of the graph for that interval. And remember how we talked about, if I can run my finger along it and it's going down, then it is a decreasing function. So on that interval, that function is decreasing. Another example, f of x is equal to 2 minus x squared. So we would clear out the expression, type in 2 minus x squared. I could also do the power key and 2 and graph. Okay, and this is the parabola that I've captured here. What's happening from negative infinity to 0? Well, again, that's my x direction, right? Negative infinity to 0 is here. So that's talking about this piece of the graph. So what's happening? Remember, we read graphs from left to right. So as we go from left to right, this function is increasing on that interval. Now the last objective is to determine symmetries and even and oddness from the calculator. So here's a function, and I just want to review how to enter the function. And I've captured the important things, but just to make sure you see me going through these steps, if I enter the expression x raised to the 5th power minus 2x raised to the 3rd power, and graph that. Okay. Now this was in the standard window. If I wanted to kind of zoom in on that, I actually did zoom and z decimal. Okay. You don't necessarily have to do that, but that's how I captured this graph here. It was a z decimal format. Now remember how we talked about symmetries. We talked about symmetry with respect to the y-axis. Symmetry with respect to the y-axis means the left side and right side of the y-axis are mirror images of each other. That's clearly not the case, right? Because to be a mirror image of this, I would have to go down and up, and I'm not doing that. To be symmetric with respect to the origin, the left side and right side of the y-axis have to be flipped images. And notice that's exactly what we have here. So this one is symmetric with respect to the origin. Now, there's a mathematical way we can do that other than just looking. Do you remember mathematically, to be symmetric with respect to the origin means that f of negative x has to be equal to the opposite of f of x. In other words, we said that opposite x values have opposite y values. And if you look at the table by pressing second graph, which I've illustrated here, notice how opposite x values have opposite y. Right, opposite x, negative 2 and 2, have a negative 16 and 16. Negative 1 and 1 have opposite values of 1 and negative 1. So this is symmetric with respect to the origin. And do you remember that's also called an odd function. Another thing, notice that all the powers involved are odd. Kind of a big clue. The next example is 0.5x to the 4th minus 2x raised to the 2nd power plus 1. Now if I graph that, and again I'm in that z decimal format, you could be in the standard window is fine. Is this symmetric with respect to the y-axis or origin? Is it even or odd? Well, symmetric with respect to the y-axis means that the left side and right side are mirror images, and that's exactly what we have here. So this is symmetric with respect to the y-axis. Mathematically, we say that to be this, that f of negative x is equal to f of x. In other words, opposite x have the same y values. Okay, and that's what happens if I press second and graph. My table, I see that opposite values for x have equal y values. And we also call that, do you remember? Opposite x have equal y, that is, yep, an even function. And what's true about the powers? 4, 2, 1 really has the power of x to the 0 attached to it. So that's an even number. I was going to tell you another thing you can do on the graph. Do you remember how you can press trace? And like if you typed in -2, sorry, I meant to do -2, enter, you see -2 corresponds to 1, but then you could type in to see what happens at the +2, and it corresponds to 1. So we see there that opposite x have equal y values. Here's another example. Clear this out. If I do f of x is equal to x to the third power minus x plus 3, and I graph it. Okay, and if I want to go back to the standard window, so zoom and 6, okay, which is what I have copied here. This is a standard window. Notice that I don't have a mirror image to the left and right of the y-axis, nor are those images flipped images of each other, or I should say those pieces are not flipped images of each other. And if I look at the table, here's the case where I have opposite x, right, -3 and 3, but their y values are neither the same nor are they opposite of each other. So this is a case where we have neither even nor odd, and there are no symmetries to report. Okay, so this is how we can use the graphing calculator to aid us in this section. If you have any questions, please don't hesitate to contact me. Thanks.